Okay, so by way of review, as I said, let's once again load our data, and then let's subset our data. Let's create this object wage1 by removing the categorical variables. And then let's create a pairs panels so that we can see the relationship of the variables among themselves, either using pairs.panels and GG or GG pairs coming from different packages. They give the same results. The only difference is that for GG pairs, it will give us the p-values, the correlation is significant or not. And so we see here that the correlation between hourly wage and number of dependents is practically zero. Okay, this value, negative 0.054. The null hypothesis there is that rho, the correlation is equal to zero. So since it's not significant, then we fail to reject that null hypothesis that the correlation between hourly wage and number of dependents is zero. But for the others, the relationship between hourly wage and education, with experience, with tenure, they're all statistically significant. For among the independent variables, as I said, we don't want that they have strong correlation. For example, experience with tenure, they're both independent variables, predictors, and you can see that the correlation is 0.5. That's moderately strong, and we don't want that. We want the independent variables to be not correlated so that there will be no ambiguity as to which of the variability of the dependent variable is being explained by the one independent variable. And we will see that when we do diagnostics. Okay, for today, what we're going to do is we're going to work on what we did last time. What we did last time was to start with a simple linear regression, regressing our hourly wage on the education. And then what we did was to load all the variables. And then step by step, what we did was to remove those variables that were not significant one at a time. That's what we call stepwise regression. That's okay, especially if we're learning the process. However, when we have a big model, when let's say we have 20 predictors, and then we're going to do that manually, that can take time, that will take long. Now we have a package that does that for us, which is the OLSRR. And I gave you a site which gives us, let me see, this is a good reference. This is, okay, where's OLSRR? Wala. Okay, so let me just copy the site. Does all of you have this class? I sent this in the chat box. Let me send it again for the benefit of those who don't have it yet. And kindly open. Okay, this is a good reference class. And I'm pretty sure we will not be able to cover everything about OLSRR, but with this reference, you can, I know you'll be able to access this and on your own learn with those for the topics that we will not be able to discuss in this class. Okay, so you have here 1, 2, 3, 4, 5, 6 main topics. You have the introduction, residual diagnostics, measures of influence, heteroscedasticity, collinearity diagnostics, and variable selection. What we did so far is variable selection. So if we click this, if we highlight that, then you'll have this variable selection methods. There are here you have several methods. You have stepwise regression. You have stepwise forward, stepwise backward, stepwise forward AIC, stepwise backward AIC, and then you have also stepwise forward p-value, stepwise backward p-value. So we're going to look at those 6 basic methods and then see how it compares with what we did last time. Now, if you recall, what we did actually is the stepwise backward regression using the p-values. So what did we do last time? What we did was to load all the predictors, okay, and then one by one remove those predictors that were not significant, basing it on the p-values or corollarily on the t-values, the lowest absolute value of t, which will give us the highest p-value, okay, and that means that it's the least significant. Okay, so let's do that now. Let's load first OLSRR here. Okay, let's load the OLSRR. I'm sure we already loaded the install the package before. So let's just load it now. And there are six methods that we can perform using OLSRR. Okay, so let me just give this to you so that you don't have to write. Save on time. You can just copy this, Control B. Okay, just copy that class, and then let's take a look at this one by one. So let's first use this stepwise regression, Control C, Control D. So the first method that we're going to use is stepwise regression, Control Alt. Okay. Now, when we do stepwise regression, it's actually a combination of forward and backward. Now, what's the difference between forward stepwise regression and backward stepwise regression? For forward stepwise regression, you start with a zero quote-unquote model or base model, where your own predictor is just the dependent variable itself, its mean, and then we add uh, our independent variables one at a time, depending on what method to use, whether it's p-value or AIC, Akaike information criterion. Okay, and then until you finally reach the final model where you cannot anymore add to your set of regressors because it will lower the AIC. So there are two methods here, AIC and P. Okay, so when you use stepwise forward regression, when you enter a variable, when you include a variable, it cannot be removed. Okay, once it's included in the model, you cannot really remove that. Okay, and of course, there's a reason for that. In the same manner, for stepwise, you load all the predictors, and then one at a time, we remove it. So that's the stepwise regression, a backward stepwise. For the stepwise regression, it's a combination of forward and backward. So it's possible to insert variables, and then in the course of the stepwise regression, it is possible to remove a variable that you have already included or loaded in the model or included in the model. Okay, so we'll see this when we perform this. So let's start with this stepwise regression using P. So what's the basis of this? The basis of this to either include or delete a variable in your model is the p-value. Okay, so let's create an object. Let's call it both. Okay, both, which means it will include both forward and backward. Both, let's call it both using P. All right. And the function here is OLS underscore step. If I type OLS underscore step, you will find here the several functions that go with it. OLS step all possible, okay, backward AIC, backward P, okay, so many of these, okay. Step AIC backward, step AIC both, which is the same as step both, and then P or AIC. Okay, let's just choose this. Step OLS step both P. Okay, but before we do this, we have to load first. We have to identify our model. So let's create this model model, LM, hourly wage is our dependent variable, regress on everything. Okay, this dot here indicates that we're going to use all the predictors in our data set, in our wage data set. Okay, I don't think I have run this, so let me run this. Run. Okay, make sure you run it, class. It's an LM object, linear model object. So we can now use that here. Okay, so for the stepwise regression using P, let's create an object called both P, and then the function is OLS step both and P. Okay, I showed you a while ago. It can be step. And just do that. So you have OLS and then step, right? Step. Okay. So we're using this step both P, but I said a while ago you can use this step AIC or step B both, right? But let's just use step and then both and then P there. And then we perform this on our object mod P, where we are regressing hourly wage on all the predictors. Okay, so let's run this. It will take a few seconds. Okay. Have it printed? Both P. Okay. I forgot something here. Kaya hindi siya nag-print kagad. Sorry. I have to put here, comma, details is equal to 2. We will ask R to print all the details. Right, sorry about that. Details is equal to true. Okay, and if we run this, Control Enter, it will now print the result. Okay, let's give it a few seconds, and then once you're done, before I explain, kindly chat yes, please. Okay, good, thank you. All right, so let's analyze the result. Okay, this is stepwise regression. Another name for this is stepwise. It's called both because it takes into consideration both forward and backward, as you will see now. Okay, so the candidate terms are the 7 variables. You notice that for stepwise regression or both, it starts with a 0 base. So it starts like a forward stepwise regression. So the candidate terms are the 7 variables. And see, we are selecting variables based on p-value. Why p-value? Because, okay, so this is the p method that we're using based on p-value. And the first one that will go in is education. Okay, so it takes a look at all the parameters, all your variables, and it chooses which of them has the lowest p-value, aka the highest t-stat. Okay, and we have here some model summary. If we're going to include education as our predictor, instead of not using any predictor, the R squared becomes Okay, if you recall this, when we did regression, the simple linear regression, just education, the adjusted R squared was 16.3 something, yeah. And then we have other measures here. You have your Ramsey, root mean square error. So how do you compute this? Squared error, you get the difference between your actual y and your predicted y, and then you square it. Okay, that's a square error. And then you get the average. Okay, you get the average of that, and then you get the square root. Okay, of course, the lower the root mean, the Ramsey, the better. Okay, so this is also another metric which other people use, the Ramsey, because they would want, of course, we want the error terms, the squared residuals to be small. Okay, so this is just the mean and then the square root. Okay, let me pause for a while. Is that clear, class? The Ramsey? Okay, so that it's important that we know this. Okay, good. All right, then we have this MSE. We'll not discuss coefficient of variation anymore. MSE is mean square error. Well, it's similar to your Ramsey, only that you're not squaring it. Okay, so if you get the square root of this, you'll get Ramsey. Okay, you can just, anyways, again, let's try that square root of your MSE. Control C. So I'm getting the square root of MSE, which will give us the Ramsey, 3.378. Okay, and this is the mean absolute deviation. The mean absolute deviation is, as the name suggests, error. This is the error term. Mean absolute deviation is your error term. Okay, so you get the y sub I minus y hat. Okay, and then, but you get the absolute value of that. So you get the difference and then get the absolute value. That's where we get absolute here. And then you get the average of everything. That's why you have a value here. Okay, remember when you get the residuals and then when you sum that up, that should be equal to 0. Okay, because that's the nature of your OLS. Okay, so we have this matrix here: root mean square error Ramsey, mean absolute error, mean square error. Okay, now here we have the ANOVA. Okay, so this one is the analysis of variance. It tests whether this is DF1, which means this is one predictor. So if you recall, this is the overall goodness of fit test, which means the null hypothesis is beta null is equal to beta 1 is equal to 0. So we reject that null hypothesis, the null hypothesis that in the intercept and your predictor education is equal to 0, where our conclusion is that at least one of them is non-zero. And then we have your estimates. Okay, this is our model. Yeah, if you recall, this is the value of your education and the value of your intercept, which if you recall, in simple linear regression natin, hindi siya significant, diba? I hope you recall this, but the education is significant. And you can see here from the confidence interval, okay, because you may know if a variable is significant or not, as far as the regression is concerned, if your confidence interval will hit 0, or if 0 is possible to be, if there's a possibility that you can have 0 here. So this is negative, this is positive, then that's there's a possibility that 0 can be a value of your intercept. That's why our p-value for the intercept is not significant. Okay, because we fail to reject the null hypothesis that our beta null is equal to 0. But for education, you have lower and upper. It's not possible for 0 to be between our confidence interval. 0 is not there. So that's why this is significant. Okay, which means that the test, the hypothesis that beta 1 is equal to 0 is rejected. All right. Then after that, we have stepwise selection, step 2. So the next step is add tenure. So what will happen? This is now our model summary. So if we add tenure, you notice that our Ramsey from 3.378, it went down to 3.092. Also, our adjusted R squared. A while ago, it was just 16% here. It was 16 lang dito. Here, 16% adjusted R squared. It increased to 29.9%. Okay, we saw this last time when we did our regression, and we were doing this manually. Okay, and also the ANOVA, we now have two predictors, and the p-value is 0, which means that we reject the null hypothesis that both predictors are equal to 0. B null is equal to B1 is equal to B2, three variables on all in all, including your intercept. Okay, so we now have this model, and we were able to see that even our intercept has already become significant. Okay, and these are the values of our parameters, and here we have our standard beta. Okay, what's a standard beta? For a standard beta, you don't have any value of the intercept. And how do we get this? We convert the variables, all the variables, education, tenure, everything. We standardize it, which means that whatever value, for example, education here. So we convert this into standardized value, which means we get the average of education. Okay, so let me just show that. Okay, let's illustrate that. Mean of wage, dollar, education. What's the average of education? So that's 12.56274. Okay, however, wait. So let me just illustrate how it's standardized. So, and then the standard deviation of wage, education, what's the standard deviation of that? Is 2.76. So how do we standardize education? So each of these values, 11 minus the mean, Control C, Control V, and then divided by the standard deviation. I'm sure you know this class. Control C, Control V. So this is in your stat, this is your X minus mean over the sigma. Okay? So that's now your negative 0.56. So you will replace this by negative 0.56. Everything there. Everything will be standardized. Your experience also, your tenure, your hourly wage, everything. So when you perform linear regression on that, those are already the standardized values. You'll get this. Okay. You'll get these predictors. This one, standard beta. Okay? And you will not have the intercept there. Okay, the intercept will be 0. So magiging 0 yan. Okay, so yun ang standard beta, no? Okay, so it's important for us to at least understand, no, what the outputs are. Okay, now that we have two predictors, we notice again that repeat lang to, no? It's just repeated. I don't know why it's repeated, and then repeated also. So we now go to step 3. And what will be placed is gender. Okay, so we have this ANOVA again, so statistically significant. Okay, and then we have now gender here. Okay, since we're using the p-value method, okay, we're only including those variables which, when you include in your model, will still be significant at 0.05. So again, a summary of the ANOVA, the values of your parameters. Okay, single. Ito yung three predictors, then naging 4 na siya ngayon. Okay, 4 na siya. And all of them are statistically significant. And then, all right, again, you have your ANOVA. And we reject the null hypothesis that beta null is equal to beta 1 is equal to beta 2 is equal to beta 3 is equal to beta 4 is equal to 0. We reject that. And these are the values of our parameters. This is the unstandardized unstandardized beta. This is the standardized beta. And you can see here that indeed these are statistically significant because the values between the confidence intervals, 95% confidence intervals, will not touch 0. Okay, and then it tells us no more variables to be added. So it stopped here because if we add another variable here, the p-value will be not significant. Okay, it will be greater than 0.05. Okay, so as far as the OLS step, both p method is concerned, this is our final model, which is just the same as our stepwise, our backward stepwise, which we did last time. If you recall, we had education, tenure, gender, and civil status as the predictors for our model. Okay, so this is our final model output. And then once again, the parameters. Okay, let me pause for a while and seek your comments, please, if you got it. Okay, thank you. Thank you. Okay, I hope the others will also comment. I got only 5 comments out of 19. Okay, good. Thank you. Okay, so let's in fact, let's try to see. You can actually, let me close this first. Let's try to see what we can plot this, plot both underscore p. Okay, let's try to see what this will give us. Plot of the object, both p. All right, and then let's see this. Okay, so this gives us a plot of the different metrics that's used. Okay, so for r squared or adjusted r squared here, you can see 4 here refers to the number of predictors. So the adjusted r squared 4, this gives us the best adjusted r squared among just one predictor, 2 or 3 or 4. AIC also 3 and 4 are almost the same, but the 4 predictors here are the best. CP, this is Mallow's CP. Okay, and it's also a measure. It's like similar to AIC, Mallow's CP. And later on we'll meet this. The lower the Mallow's CP, the better, just like AIC. Okay, EK. And then here is R squared also. Then we have here another one. We have Schwarz-Bayesian information criterion, which is just the same as your AIC, and also this one. Okay. All right. So let's now go to the next model. Copy this. Control C. Control V. Let's just change. So this is number 2. Now we now have stepwise regression using AIC. Let's see the difference between using AIC and AIC. So this is both AIC, OLS, step, both. Let's call this AIC. All right, details is equal to true. And then later we'll plot AIC. Okay, let's run this first. Let's run AIC. So once again, this is both, which means it includes both stepwise forward and backward. Okay, so how does this start? Okay, so just like step both P, you start with that's just like a clean slate. So nothing, no predictors, and then so these are the candidate terms. Okay, let's take a look at this. All right, step 0. So now, if you're not going to use any of these predictors, our Akaike information criterion will be 2870, and it's the same as regressing hourly wage on 1, which means the intercept. Okay, if you run this class, let's just do that for purposes of summary, and then let's call it. Let me just use LM of hourly wage tilde 1 data is equal to wage. Okay, so I'm regressing hourly wage on 1. Okay, when we do that class, we're saying that we're just using the average, or that's the intercept. Okay, so let's run this, and we can see here that let me run it again, give more space, up. Okay, so our model, take a look at our model, please. This one, just the intercept, no predictors, right? And let's see, I should have given this a name. Okay, let me run this again. I'll call this model 00. All right, so I created this model mod 00, and I won't get the name, I won't get the summary anymore. Okay, and then I'll get the AIC of mod 00. Let's see if it tallies with the one that we have. 2870 121. About 2870 121, which is this one. Okay, let me pause for a while, class. I just illustrated to you what will happen if we regressed hourly wage on 1, which means that you're not using the predictors, you're not using the variables. We're just using the hourly wage itself. Okay, any questions so far? Kindly chat, please, if you're okay so far. Waiting for the rest to give their feedback. Okay, so I just showed here to you that here for model 00, we're not using the predictors. Okay, where did this come from? This one, the value of your intercept, 5.896. That's just the average first here. Okay, so we're not using the education, we're not using any of the independent variables. Let's just use the value of y. Let's just use the value of hourly wage. So what's the most logical thing to do? We can use the median, but we will discuss that when we go to a quantile regression. In this case, for OLS, we use the mean. Okay, so the AIC for our base model is 2870. Now, will introducing a variable improve the AIC? Let's take a look at this. So let's enter new variables. So here are the options. If we introduce education, AIC will become 2777. Okay, from 2870. In fact, take a look at this. It's interesting. If we introduce race, as a predictor, AIC will even increase. So it would have been better not to use race at all, because AIC, if we were just using the average, gives us 2870 Akaike. But if we introduce race, the AIC will be higher, 2871. Okay, so it doesn't make sense even to include race. The information criterion loss will be greater. So the best one is education. This is a range from lowest AIC to highest. So since for stepwise you only introduce one variable at a time, then we will introduce education first. Okay, so we introduce education first as a variable. So that's plus education. The AIC now becomes 2777 from 2780. Went down. Remember, this is OLS step both AIC. The basis is AIC. The model is now hourly wage. Okay. All right. So we now go to the next one. So enter new variables. So here we don't have any option yet for removing variables. So if we add tenure, AIC will become 2685. So this will improve our Akaike, right? From 2777 to 2685. And if we include race, okay, the model will become poorer, because from 2777 it will become 2779. Or also insert number of dependents, then the AIC will become 2778. All right, so what do we do here? We insert tenure. So plus tenure here. And the AIC became 2685. Okay, so this is now our model. Okay, and then this is now the, okay, now we now have the option. Are we going to remove some variables? Because this is what the both method does, the stepwise regression. For stepwise regression, without qualification of forward or backward, you can remove, you can add at any time. Okay, variables that you have inserted, you can remove. Variables that you have removed, you can add back. Okay, that's why we're being asked. The model is showing us remove existing variables. Okay, let's see. If you remove tenure, then you will go back to the previous model where AIC is 2777. Because in this case, you just include the tenure, right? Okay, so it doesn't make sense to remove it. But what if you remove education? If we remove education, okay, what will happen? So it will only be tenure. Our AIC will be 2804. So there will be a deterioration in terms of AIC, because you now have an AIC of 2685. It will become 2804, right? Tataas siya. So that's not good. We want the lower the AIC, the better. All right. So we're not going to remove any existing variable, but let's see below. Are we going to add a new variable? Okay, here are the candidates. If we add gender, our AIC will become 2643 as compared to 2685 now. So there will be an improvement. If we add race, it will become 2687. So our model will become poorer. Okay. So of course, the best choice is add gender. All right, and then this tells us what will happen if we add gender. What will be the what will happen to our adjusted R squared? All right, so we add gender here. Now we have this new AIC. This is now our model. Hourly wage regress on these three variables. Okay, and then so next, we then have an option again to remove or to add. Removing any of the variables that have already been entered will only make the model poor. Okay, it will only increase your AIC. So nothing here, nothing here. How about adding a new variable? From 2643, okay, if we add civil status, it will become 2639. Okay, in fact, if we add also experience, it will become 2640. it will improve still. However, why choose experience when by including civil status, the AIC will become smaller as compared to including experience. So we add here civil status. Okay, so our AIC now is 2639, education, tenure, gender, civil status. So are we going to remove any of the existing variables? By removing any of them, it will make our model worse. Okay, entering a new variable. Oops. If we enter experience, our AIC will become 2638 as compared to 2639 now. So should it be added based on AIC? Yes. So plus experience. So we now have an AIC of 2638.6. These are now our predictors. Once again, we're shown, do we remove anything here? No, because if we remove anything here, it will increase AIC. And then, do we add new variables? 2638.8, if we add number of dependents, our current AIC is 2638.6. Okay, so AIC will increase if we add number of dependents. Therefore, okay, no more variables to be added or removed. Okay, all right, and this will be our final model. Okay, again, the ANOVA is that all the betas are 0, so we reject that. And then you can see here that these are our predictors. Okay, these are their values. Okay. However, what do you notice, class? What's the difference between this one, the both P and the both AIC? Did we come up with the same model, class? Did we arrive at the same model? Anyone, please? See, Ivan, would you like to answer that? Is Ivan here? Ramil? Hello, Ivan. Wala, attendance sa class, ha? Kasi I noticed that some will just have their attendance check and then will be gone. That happened to me several times already. I'll just take note of that. I'm writing it down. Okay, Steph, what about you?
Sir,
Yes, what about you? What do you think? How does that compare? This one, our output here, compared to the previous one that we did, the first model that we did. Steph, Sir Bora?
yes, sir.
Yeah. Were you listening?
Yes, I can't, sir, I don't know how to compare it po
Huh?
from the previous.
Just take a look at the previous model. Ano yung mga predictors natin dun sa previous model? Dapat class, madali sana yan kung nakikinig kayo, ha? Very obvious yung ano yung answer diyan. Yes, what about Carlos? Sige. Kasi hindi yata nakikinig si Steph eh. Steph, nakikinig ka ba? Dapat kitang-kita niyo yung answer. Carlos, could you kindly answer that? What do you mean by that? What do you mean by your answer?
Hi, sir. From a while ago, I remember that the predictors were different. Sorry, sir, I can't load it po kasi right now with my R Studio because I have to update my OLS. But
Okay.
I'm copying po and I'm watching the lecture. So I remember po the predictors used to be different sa first model.
Okay, how different? Can anybody answer, please? Just tell me the difference. What's different about our model now and the previous one, the both P? Yung first
Sir,
model natin. Yes?
there's no expert po in the first model.
All right. Who's this?
This is Angel, sir.
Angel, yes, Angel. Ano yung difference?
There's no expert in the first model.
All right. Yeah, correct. Thank you, Angel. No? So dito, class, you can see that for the first model, you had education, tenure, gender, civil status, but no expert, no experience. For the AIC method, you have 5 predictors: education, tenure, gender, civil status. The only difference is that yung first natin, walang experience. The next one here has an experience. You know why? Because based on AIC, the additional experience class lowered the AIC. However, what's glaring about this? Kindly take a look at this model. What do you notice? Is there something here that you notice? Okay, thank you, John. Okay, but what do you notice about this model? There's something glaring about this which will make you wonder. Focus on the third to the last column. You notice something, class? Third to the last column. Pwede i-unmute. You can unmute yourself, class.
Sir?
Yes. Who's this?
Carlos po, sir.
Yes, Carlos, yes.
The was that 0 is possible for both the civic status and expert?
Sorry. 0 is what?
It's possible po since the lower limit for the civil status and expert is negative and then the upper is positive po. So like
Okay.
still is possible.
Okay, so what's the implication of this if the lower is negative and the upper is positive? Okay, I thank you, Carlos. But that's actually that's an explanation of the answer. But John, can you unmute yourself? You mentioned something here.
Sir,
Hindi, si
following,
John ba yun? Ikaw ba yun?
ay,
Yes. Oh, ikaw yung unang nag-post. Pareho kayo ni Christian. Okay, yes,
sir,
John.
following 95 confidence interval, the save status single and expert are insignificant since the significant level is greater than 0.05.
Yeah, ito, yun nyo. These two. So in this model, in this method, both the civil status and the experience are not significant. Their p-values are greater than 0.05. And this is disregarded if we're doing AIC because the focus, the basis is AIC. On the other hand, for the first model that we did, all the predictors that were included are all statistically significant. Okay, so we can say that this might be a weakness of this model. Okay, because strictly speaking, if we are going to infer, and as mentioned by Carlos and by John, you notice the confidence interval here. It ranges from negative 1.121 to 0.003, which means there's a possibility that 0 is contained in this range. So if we're testing the null hypothesis that the beta for civil status is equal to 0, we cannot reject that. We cannot reject that hypothesis because it's possible that beta sub 4 is equal to 0 because the confidence interval contains the value 0 here. And so with experience. Okay, so this is the difference between your both P and your both AIC. Okay. All right. So, sige. let's go back. Well, sorry. So let me now, okay, close this. And then if we plot, let's plot the both AIC model that we generated. Okay, so here, it will give us, okay, the variables that were introduced. Stepwise AIC, both direction. Okay, so the both there means both direction, forward or backward. As I showed you a while ago, we are shown the option, what will happen if we remove some of the variables that already were integrated into the model. Okay, so these are the variables that will be included in the model, education, and then you can see here that the basis is AIC. So introducing these variables lowers your AIC, okay, up to experience. So if we increase this, if we introduce, I think the next one is, I think, number of dependents, it will now increase our AIC. So it's stopped up to this one. Okay, let me pause for a while. Any questions, class? Kindly chat, please, if our discussion is clear so far. Okay, good. Thank you. All right, thank you. Okay, so let's move on. And let's now go to forward. Okay, the first two we were using both direction, but now let's go to one direction. Let's copy this and then just change. Oops. Okay, let's call this number 3, and then this is forward. Forward stepwise regression using, let's use P first, P. P, and then let's call this forward, 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 P. Okay, this is now, the function is now forward. Very easy to remember. OLS step forward, OLS step backward, and then you identify whether it's a P or a AAC. Okay, again, let's include the details. And then let's have this plotted also, forward, and then P. So for forward regression, forward stepwise regression, you start with the base. Again, no parameters. And then we introduce one by one the most significant of the predictors until such time that you can no longer insert or include any variable, because that will be insignificant. Okay. In this, the only difference here is that in forward, you're not allowed to remove any variable anymore. Unlike in the both, unlike in the regular stepwise, you can remove a variable that you have already introduced. Okay, so let's run this. Let's just run the first one. Okay, and we will not anymore go through the details of this because I know you already understand this. Let's just go to the last, the final result. Okay, so the final result will be, okay, maybe let's go the previous one. All right, so, okay, here. So we have already introduced education, tenure, and gender. All of them are significant. Okay, here it tells us that forward selection, step 4, add civil status. Okay, why? It will be added because adding civil status will still have a p-value of 0.013. So this is still significant. Okay, and then forward selection. Okay, number 5. Will you add experience? Okay, so if we add experience, All right. Note, it added experience, right? 0.12. Okay. And then it added number of dependents whose p-value 0.184, the p-value. Okay. So no more variables to be added. 1, 2, 3, 4, 5, 6. So why is it that you have 6 predictors here? We're using forward, right? OLS step forward P. Why did it include these variables whose p-values are greater than 0.05? Anyone? Class? Could anyone venture a guess? Okay. Check this out, class, and see if you can find the answer here. When you encounter problems with a particular function, it's always a good idea to seek the help function of R is really very comprehensive. That has been my help, no, for since I started using R. Okay, what do you see? Can somebody please tell me what you discovered in this? Anyone, please?
Sir,
Yes?
may I take a guess?
Yeah, sure. Sure.
I think, sir, based on the description, it naturally includes all regressors, regardless of whether they're insignificant or not. And like it exhausts all independent variables.
All? Okay, let's check, ha? Kasi ito yung candidates natin, di ba? 7. Di ba? There are 7 regressors. But how many regressors are in the final module? 1, 2, 3, 4, 5, 6. 6 lang eh. Ba? So it's not all. You have 7 candidate variables. Only 7 were chosen. Okay? Read more, guys. Nasa ano siya? Nasa guide. Tingnan nyo. Tingnan nyo yung syntax ng guide. May nakalagay doon. Something's written there. A default value, which will answer that question. What is the default value? Class, dito sa model na to, dito sa function na to. It defined what the default value is. Anyone, please? This is a good opportunity for you to learn how to make use of the help function in R. But who's that? Angel? Angel, ikaw ba yan? Angel, was that
Correct,
you?
sir.
Yeah, thank you, Angel, for answering. Tingnan yung class yung example. Take a look at okay, let me, okay, this one. Okay, it's here. It's here, class. It's here. In the usage. Tingnan yung usage. Andyan yun. Andyan. It's there. Anyone, please? It's there. It's printed. Andyan, nakasulat, no, class? You only need to look at this portion, and you will already see the answer to that question. Okay, I
There
think
is a point 3.
yes. What about point 3?
If tama po pagkakaintindi ko, it will
Okay.
include p-values na lower than 0.3.
Okay. Thank you, Margaret. That's correct. That's correct. So the level of significance used, and I don't know why. I don't know why. R is it's a statistical package. I don't know why they defaulted it to be 0.3. Okay, so if you take a look at the final model, diba, the p-values here are all less than 0.3. Ayun. And that's why it didn't include the last predictor, because if we include it, the p-value of that predictor is greater than 0.3. Okay, so this for our purposes is not acceptable. So we will have to tweak the default model a bit. And so let's tweak it. Let's put here p enter. Okay, p enter is equal to 0.05, which means that what will only enter in our model are those whose p-values are 0.05. Okay, go class, kindly run that and please chat and tell me if now your p-values are, your predictors contain p-values that are less than 0.05. Would you kindly chat, please? So this is what we need to adjust, because the default, okay, if you don't define the p enter, it will be 0.3 because that's the default of OLSRR, which I'm really wondering why they use that as a default. Okay, kindly chat, please, if you have a solution now where the p-values are less than 0.05. So that should be only up to civil status. Okay, so waiting for the others to key in there. Okay. Okay, good, good. Thank you. Thank you so much, class. So let's now plot this. Okay, so I hope we address that problem. Okay, be sure when you're using forward to make sure that you define what the p enter is. Okay, which means that variables with a level of significance that's less than 0.05 are the only ones that should be chosen. So let's plot that forward p, this object. Oh wait, sorry, I have to run this. I haven't run the one with the p enter. Okay, of course, class, if you don't want to generate all the steps, you can just remove these details. Okay, so let me illustrate that. I don't want to generate all the step by step. So I'll just remove the details is equal to true because the default is details is equal to false. Okay, take a look at this. Details is equal to false. So if I run this, okay, it will now okay, so we will have, because I deleted details is equal to true, I will have now to print this forward p. It will not automatically print itself. All right, so this one. So this is now our final model, this one. Okay. When I remove details is equal to true, it did not automatically print. That's why I had to have this printed. And then the plot class, the plot will look like this. It will once again tell us, okay, so based on R squared, okay, the Mallow's CP. So there are four variables here. So very consistent, okay. Schwartz Bayesian information criterion, etc. Okay, we can of course have other information about this, but let's move on first. And then let's just Control C, Control V very quickly now. Let's number 4, and then let me just Control F. The P I'm going to replace by AIC. AIC, okay. Oops, no, not that. Not that. Next. Okay, that one. Replace. Okay, this one. Okay, replace. Step, no. Next. Next. Oops, yes. Previous. Okay, replace. AIC. This one, no. Next. And then this one, yes. Replace. All right. And no. Next. And then replace. All right. I just replaced everything, the piece with the AIC, except those pieces that are not supposed to be replaced. Okay, so all right. This one, let me also, now for this one, since it's AIC, you don't need to put here the P enter, because P enter will not be the basis. Okay, so let me just put here details is equal to true again. Right, so no need to print this because it will automatically print already. Details is equal to true, so it will automatically print the model based on AIC. And just like a while ago, okay, it will include variables, okay, even if they're not statistically significant. So the forward AIC generates the same output as the both AIC, okay, in this case. In other cases, they will be different. All right. So even if they're not statistically significant, they're included because it led to the AIC becoming less here. Step 5, include experience. AIC dropped down from 2638 to I think 2639, right? Okay, so that's the reason why experience was added, despite the fact that experience is not statistically significant. All right, and then if we once again plot this forward AIC, you'll find out here what were the variables that were included, just like the one above, the both AIC. Okay, all right. I hope I'm not going too fast. I'm sorry because in the interest of time. All right, and then I'll just discuss this, the backward stepwise regression using P, and then I leave you guys to look at the backward using AIC. Control C, and then Control B. So this is now 5. This is now backward using P, all right? Backward P. Dami pala nitong forward, no? Sana inano ko na lang. Backward P. Control C. Dapat P9 ko na lang. Control B. Control B. All right. So this is similar to what we did. But this time, it should not be. Lagyan natin dito class ang details is equal to true. And then let's not print it anymore because it will be automatically printed. And then it will not be P enter. Kasi di ba pag backward, you include first all the variables and then hindi P enter but rather P remain. P rem, no? Means remaining. Yung matitira, sino yung matitira? Dapat yung P values niya dapat less than 0.05. Okay, Control Enter. Then once again, it will run. Okay, kindly on your own look at the process, which is just the same as what we did before. Okay, tingnan nyo, no? Okay, backward elimination. No? Okay, so ito, backward elimination, these are the candidates to be removed because these are the parameters or the variables that are already included in the model. So we are eliminating variables based on p-values. So eliminate race first. Why? Okay. So variable p eliminated. It's based on the t-value plus. It has the lowest absolute t-value, so race was removed. Okay, so what happened was, this is now our model without race. So ang susunod na naman yan, you know what to do with this one, class? The next one is remove number of dependents because it has the lowest lowest absolute p-value. That's why it says here X, remove number of dependents. That's backward elimination step 2. Okay, and so on and so forth until such time, class, that it says here that variables removed, race, number of dependents, experience. Okay, final model output already. All right, so all of these variables are now statistically significant. Okay, so that's our final model. And if we plot this plot, right, we can see here, okay, all right, so for adjusted R squared, why are there 3 only? Okay, something's wrong with this one. Backward P, tama naman. Backward P, why? Okay, so, okay, this backward kasi class, this tells us what were the variables that were deleted. No? So remove si race, remove si number of dependents, remove si experience. So 3 variables removed. And the adjusted R squared and the R squared went down. Of course, we expect the R squared to go down because you're removing variables, okay? And here, the Mallows CP from 6.1, okay, then it went down to less than 5. So this is okay. But notice now that the Mallows CP increased here. So this is interesting. Kasi generally, yung Mallows CP, the best model is the one with the lowest Mallows CP. Okay? So there seems to be just like AIC, take a look. Mallows CP behave as AIC. So if you notice here, if we remove 2, you'll have a lower AIC as compared to this one. So here it's now a sacrifice, it's a compromise between your p-values and your AIC. This will have a higher AIC, however, all the variables will be significant. Okay, I leave you guys to do backward step regression using AIC. It's almost time. Let me just point out to you, okay, very quickly, class, sorry if I have to extend a bit, no? Your permission, class, to extend by just around 2 minutes. No? Because I want you, class, your assignment will be to look at the this one. Okay, what we have done is more of the variable selection methods. So this one, we can use this. Okay, let's run this OLS step, all the possible models. Okay, if I copy this, Control C, and then run it, Control Alt I, Control D, and then we name this mod. Okay, what will this give us? And then let's just call this as let's call it X na lang, no? The all, I call it all underscore mod, all models, alt minus. All right, and then let's view it, view all mod in one line. All right, so we're using the OLS step all possible, and then run this so that it prints to us. Okay, take a look at this. There are 127 observations here. And it gives us, class, ang bilis, ano? It gives us all the possible combinations. Okay, here 1 means, the 1 here means yung N, 1 predictor lang. So if you're just using 1 predictor, if you base it on adjusted R squared, education is the best. To take a look at this, race, in fact, will give us a negative adjusted R squared. Okay, so there's this CP also, AIC, etc. Okay, if you have two predictors, so marami yan, education with tenure, education gender, etc., etc. All in all, there are 127 possible combinations. How did you get 127? Okay, the formula is 2 raised to the 2 raised to the predictors, okay, minus 1. Right, so let's run this. 2 raised to the number of predictors. The number of predictors is, we can get it from the number of columns. Okay, parenthesis n column of wage. Okay, isn't it that there are 8 columns in wage, but we have to subtract 1 because 1 is hourly wage. So there should only be 7 predictors. Okay, and then we subtract 1. So that's 2 raised to the k minus 1. Okay. Sorry. May kulang ako. And then subtract 1. So 2 to the k, where k is the number of predictors minus 1. So this gives us 127 all in all. Okay, this one. And then you can actually print this. Okay. So just this last one, class. You can have this. Another one here is we can plot k, right? So if we plot where's that? Plot all mod, right? That's our object. There. Okay, so what does this tell us? All right, so here, okay, if you're basing it on adjusted R squared, okay, take a look at this. If you only have one predictor, then choose model 1. And model 1 is education. If you have 2 predictors, then based on adjusted R squared, choose model 8. What's model 8, class? This is model 8. All mod. Model 8 is, let's say, index number here. Model 8, this one. So you choose education and tenure. All right. For 3, you should choose 29. For 4, you should choose 64. Okay, so if you have 4 predictors, what should be the model? 64. We're told it's 64. Okay, so it's education, tenure, gender, civil status, which is what we arrived at, right? This one, if there are 4 predictors. Okay, so let me stop there, class. Okay, for next meeting, we're going to complete this. Your assignment, class, will be, of course, we will really push with the group quote-unquote sheet work, graded sheet work. And then I want you to read, okay, the different guides here. Residual diagnostics. What do you do in order to determine? If you take a look at this, in diagnostics ng residuals. Okay, the QQ plot, normality test, the residual versus fitted test, histogram, etc. Right, so your assignment will be try to use this with our model number, the model that we created. Okay, so let me stop recording now.